For this last session, we're going to talk about visualization. We'll primarily be using ggplot2, and that's now a part of the tidyverse package. So if you've installed and loaded tidyverse, then you've also got ggplot2. We'll also be using scales, the scales package, so you should install that. And the slides do include a section where we talk about how to plot maps, and that is using the ggmaps package. So if you've generated plots before in MATLAB or Matplotlib or PyPlot in Julia, you might be familiar to this other framework of plotting, where you basically give the computer some vector that you want to plot and just say put this on this plot in a line, and every time you get some new observation, you create a new vector and you say, oh, now I have this new data, plot this. And that's what I consider a more traditional way of plotting. However, as your data gets bigger, it turns out this isn't the best way to plot, because every time you have a new observation, you might have to change your code for plotting. And when you have tons of data just streaming in, that's changing your code every time you get new data isn't really a viable option. And as a solution to that, there's this idea or framework of the grammar of graphics, and that's where you describe the logic of how you want to plot your data, and then based on the specific details of what data you have, the computer kind of understands and interprets your logic and generates that plot. And that might not make a lot of sense in words, so let's just look at an example. Okay, say we have this table here. Okay, so we have two groups, Group A and Group B. They each have some kind of score, a measurement that we got at time 1 and 2. Now we want to draw a line, for example, for each group, where the x-axis is the time. So let's just generate that data. So time is 1, 2, and we have some Group A with scores 2, 6. We have Group B with scores 3, 5. Okay, so I'm going to generate that data. Now, in R, with the base R function, you can generate plots the traditional way. So I'm going to plot time and first A, and I want the type to be a line, and I want the color to be red, right? You can see here I have, an okay plot. Now if I want to add the group B, then I have to write another lines and say, oh, here's a new vector B, and I want the color for that to be blue. There, right? So that's fine. But then what happens when you get another group C? Then you'll have to create that new vector C and provide some kind of data to it, and you have to add another line like this. Namely, you'll have to change your code not only for generating and saving the data, but also for generating the plot. Now let's take a look at this in the ggplot way. So let's just first load library. I'm going to load tidyverse. Okay. So to use ggplot effectively and efficiently, it's best if you have your data frame in the tidy format, which we discussed in the second session. So first, let's just create a table that's identical to the one presented here. So we have a time column, which is the time vector now, and we also have a column A and column B. Okay, sorry. And now we know from the previous session that this data table is not in a tidy form, since our variables are time, group, and score. So we want to gather this data frame, so I'm going to call the new data frame df tidy. And from the original df, I want to gather where the key is group, the value I'm going to call score, and we want to gather the columns A to B. So here our df_tidy now has that better form where each column is a variable and each row is an observation. Now you don't have to understand the syntax of ggplot yet, but let me give you the idea of how ggplot works. So you assign to this variable a ggplot object using the data df_tidy, and now with ggplot, instead of plotting each individual vector, I describe how I want a plot generated from this data frame. So I say I want the x-axis to be defined by time in the data frame. The y-axis should represent the score column of my data frame. And then I tell ggplot I want to draw a line given the data, but I want the colors to depend on the group variable inside. So this second column of the data frame, right? And you just run that, and to see it, we run p, and we have a similar plot to the one before. Except now in this case, if we have another observation of some other groups, all we have to do is add more rows to df_tidy, right? So if we had a group C, there might be a time 1, C, and some score, and we don't have to touch this logic of generating the plot, because adding more data doesn't affect the logic of how we want to generate this plot. So that is the benefit of ggplot, and in general the idea of the grammar of graphics. Most visualization tasks that we're going to talk about in this course will fall into either one of these categories. And the goal for this session is just to introduce you to the concepts of ggplot and visualization, so that you know what to Google when you're stuck. Also, like I mentioned, ggplot2 is part of Tidyverse, but if you want to install ggplot2 just as a standalone package, you can also do that. For the session, we'll be mainly using 3 datasets. One is the quakes dataset, which is the location in longitude, latitude, and depth, and the magnitude and IDs of reporting stations for 1,000 seismic events, so earthquakes. And then the economics dataset contains monthly US economic time series data, so things like unemployment and population data. Then the MPG dataset is a subset of the fuel economy data. And we can take a quick look at each dataset from the help. So you can do question mark, quakes. This is you can see here from the documentation that quakes is just part of base R. Or economics, which is part of ggplot2, and here you can see what columns we have. They have date and unemployment, population, etc. And finally, we're also going to take a look at the MPG dataset, which is also part of ggplot2. And here we have the manufacturer model, or engine displacement, year of manufacture, number of cylinders, and city mileage, highway mileage, fuel type, class. So in the very beginning of ggplot, you create a ggplot object using the function named ggplot. Now note there's no to in the function, it's just ggplot. And you provide a data. Let's start with the quakes data. And you might note that nothing really happens. You're just assigning this ggplot object into that variable p. And to see something, you have to actually run p. And you'll notice here I have a blank canvas. And that's exactly what's happening. Now ggplot knows you want to generate a plot from this data, but it has no idea what you want to do with the data, so it just starts off with a blank canvas. So let's try tell ggplot what we want to use as an x or y axis. And these plotting the objects that we plot are called aesthetics in ggplot. And the way we assign aesthetics is by using a function called AES within ggplot functions. So we say AES, open close parens, and let's say we want to plot the depth on the x-axis, so x equals depth, and the magnitude on the y-axis. And if we run that, and we plot P again, ggplot doesn't know what we want to plot specifically on the canvas, but it does know that we want to use the depth data inside the data frame as our x-axis, and the magnitude data as the y-axis. So it's generated these basic default grids from the data that we have. It knows what the max and minimums are, and it has a good idea of what we would need to plot using these two variables. But now let's try to actually add some informative markings on this canvas, and those markings in ggplot2 lingo are called geometries. And you literally add geometries onto a ggplot object. So from this command, from the ggplot command, let's add with a plus sign a geometry, say points, which you write use geom underscore point, open close parens, and now we see we have 1 point for each observation. So this is just an example of how you could use ggplot, and we're going to talk more about the geometries and the aesthetics that are available. Before moving forward, I'd like to quickly talk about saving. So one way to save a plot once you've generated it is to use this export button. And you can save as image, and you can control the size and everything, choose the directory. But involving you interacting with your computer isn't really a good workflow, especially when you plan to have a lot of data and you want to save a lot of plots on the way. So I highly recommend that you use the ggsave function, which lets you save your plots onto your disk. Now, just a reminder, you can see where you're working on using getwd, or you can just take a quick look here, and you can see that I'm working in my home, which is represented by a tilde and temp. And you can also change the working directory with setwd. For example, if I wanted to go up one directory, I can just set wd ... And I'm just going to go back into the temp directory like that. And ggsave, you specify as a first argument the file name you want to save in relative to your current working directory. So if I just want to save in my current working directory, I would write something like my plot dot. And the neat thing about ggsave is that it will recognize the file type from the file extension you provided. And some of the available options are PDF or JPG, and PNG work fine too. So let's just say PNG. And by default, ggsave will use the plot that you most recently generated, but it's always a good idea to explicitly say which plot you mean to save. Okay, so if I do that, then I can go into my home temp directory, and here you can see my plot.png was generated. Also, I found that it's often useful to specify a width and height. So you can do that with width equals and write it the width you desire in inches. And I usually use just 5-inch width and 5-inch heights, because that seems to look okay most of the time. But you can always experiment with different options. That's height without an S. There we go. There are many more things you can specify in ggsave, such as the pixel density and all kinds of things, which you can, again, always look up with the documentation, !ggsave. Next, let's look at plotting single variables. So we'll take a look at how we plot single variables and then two variables, and then we'll look at how we adjust some visual details. So single variable, when you're looking into a single variable, you're probably just trying to plot the distribution, which you do with a geometry called histogram. So here, for example, let's try plotting. So I'm going to create a ggplot with quakes and map the aesthetic. Since we're only interested in one variable, we just provide the x-axis, stations in this case. So let's just try to generate a histogram of the number of reports we get from each station. And that's as simple as adding this geom histogram. And we plot that. And you'll notice that you get this small warning message saying that geom histogram used the default value of bins equals 30. And you should pick a better value using bin width. But still, we get a reasonable histogram here if you look on the right. But let's try adjusting the bin width. So the bin width defines how big these gaps are between each bar. And the default behavior is to make it such that you have 30 bars, so 30 bins. That's not always going to be ideal. Let's try adjust the bin width to 10 in this case. And you can see the bins have gotten larger, and as a result, we have fewer bins. And whenever you're plotting histograms, it makes sense to experiment a bit with the bin width to make sure you're getting a good representation of your data. If you look into the documentation of geom histogram, and you can see you have these different arguments that you can use, bin width and bins. Now if you go into the arguments, you can see that the bin width is the width of the bins, and the bins is the number of bins, but it's overridden by the bin width. So if you want to prescribe the number of bins to use, then you shouldn't provide any arguments to bin width. Otherwise, the bin width will override your bins argument. So just to know, and again, it's always a good idea to check out the documentation to make sure that you understand the behavior of what you're using. Some people might prefer to have a histogram where the y-axis is not a count but a density, so that the whole thing integrates into one. And to do that, you actually specify that the y-axis should be a density inside geom histogram. The way we do that is using the AES function inside geom histogram, and we'll be talking about how to use aesthetics inside other geometries soon. And you just specify y equals ... density ... Now remember, the dot doesn't necessarily mean anything in R. The ... density ... is just a name, a variable name for a constant. So I guess it's a constant name. It's the name of a constant defined inside ggplot, and that just tells the geom histogram to use the density as the y-axis instead of the count. So if we run that, you can see it basically looks the same, except the y-axis now shows the density of each bin. And we have an exercise that you can all try. Now we are going to talk about two variable plots, and from my experience, it's usually plotting points and lines. So we're primarily going to talk about that. So let's first talk about plotting points. Again, we will start with the quakes data. And this time, let's try plot the longitude on the x-axis, so x equals long, and the latitude on the y-axis. So it will basically look kind of like a map. And to that, we add the geometry point. So here, it's as simple as that. Now there are some aesthetics that you can describe specifically for points, and those are alpha, which prescribe the transparency of each point, and color, which obviously describes the color, and you can try in R run colors open close parens to see a bunch of color names that you can use inside R as strings. But the basics are all there, like red, blue, green, or yellow. You can all use those. And if you want more detail, you can always use these two. And then you can, for points, you can describe a shape that you want for each point, or you can describe the size of each point. And fill is a little confusing, but it's also a color to fill the points, but it only works for certain shapes. So on the next slide, I have a reference of all the shapes that you can use inside of a point geometry. And only these 5 points actually have a fill. So it doesn't make sense to use fills unless you're using one or more of these 5 points. And we'll soon talk about aesthetics, but let's first cover geom lines, another geometry that you would use with two-dimensional data. So this time, let's try plotting the economics data and see how unemployment is changing with respect to time. So I'm going to do ggplot economics and AES. So X is given by date and Y is given by unemployed. Now these are just column names, remember? And to that, I'm going to add the line geometry with geom line. And run P, and just as simple as that. As with the point geometry, we have a few aesthetics specific to the line geometry. Some things we have in common are alpha and color and size. Here size refers to the thickness of each line. And then particular to line, we have a line type. And if you see the next slide, these are the line types you can use. So you provide these names in quotes, so as a string. In my experience, I don't think I've ever used more than 3 line types, because once you have a dotted line, a dashed line, and a solid line, the other types kind of get confusing. Now, this is an important note on the AES argument. So you might see the AES function can be used inside ggplot like we did when we're defining the x and y axes. Or, like in the histogram, we used AES to define something inside the geometry. Or we could define some mapping of an aesthetic, so the color or shape, inside of the geometry but outside of AES. And I think this is much easier to understand with an example. Now when you use AES inside of ggplot, the ggplot function, that means you want that mapping to be global throughout the entire plot. So if I use the quakes data again and set longitude, latitude, and say I just set the size to mag. So this means within the AES function, this means I want the size of each whatever it is to be defined by the mag variable, right? And I'm going to add a point to this, not a line. And now you can see that the size of each point is different, and I have this legend telling me that these different sizes refer to the different values of mag, right? But now let's say, regardless of the data, I just want all these points to be transparent. Say I want an alpha of 0.3 explicitly. Then I say within the geom point function, I can set the alpha to some value, in this case 0.3. You can see all the points have the same alpha point, namely 0.3. But if I wanted the colors to be determined by some value, say for example the depth, then I would have to map the color aesthetic to the depth variable. And whenever you want to map some aesthetic to a variable inside your data frame, you have to use the AES function. So now I want the color to be determined by the depth variable. And now you see that the color is mapped to depth. Now, ggplot again is this canvas where you literally add geometries onto, and you can also add more geometries on top of each other. So for example, say on top of this geom point, I want to add another point. Now this time I just want to add, say for example, small red dots on the middle of all these dots. So I will add, I want the size to be unilaterally 1. And I want the color to be red. So you can do that, and you will see on top of the previous points we had, we now added these small red dots. And once you understand how these aesthetic mappings work, then a lot of the plotting with ggplot becomes quite straightforward. I think the best way to try to understand this is through exercise. So I have a few exercises which you should be able to complete in about 20 to 30 minutes, and the solutions are also available in the slides.